Here we have a problem in trigonometry. Let's go over the question. If sine theta equals to 1 over 8 and theta is in quadrant 1, then find the value of sine 2 theta. Okay, first let's write the formula for sine 2 theta. Actually, we have to write the double angle identity because here the angle theta is multiplied by 2. So we have to write the double angle identity for sine 2 theta. That is sine 2 theta is equal to 2 times sine theta times cosine theta. Okay, here to get the value of sine 2 theta, I have to multiply sine theta and cosine theta. Further, the result has to be multiplied by 2. I know the value of sine theta that is given in the question itself, that is 1 over 8. But I need the value of cosine theta. Okay, let's find the value of cosine theta. Okay, to get the value of cosine theta, I'm just going to use the Pythagorean identity in trigonometry. That is sine square theta positive cosine square theta equals to 1. Okay, now I need the value of cosine theta. So I have to solve for cosine theta in this identity. So for that, I have to subtract sine square theta from both sides. Then I'll be getting cosine square theta equals to 1 negative sine square theta. Okay, now we can plug in the value for sine theta. That is 1 over 8. So cosine square theta equals to 1 negative 1 over 8, the whole square. So cosine square theta is equal to 1 negative 1 over 64. So finally, cosine square theta equals to, when I simplify this one, I'll be getting 63 over 64 because 1 times 64 is 64. 64 minus 1 is just 63. Okay, now I got the value of cosine square theta, but I need the value of cosine theta. So for that, I have to get rid of this square we have for this cosine. To get rid of this square, I have to take square root on both sides. So the square root and square will cancel out. I get cosine theta equals to, and whenever I take square root for a number, the sign of the square root value will be positive or negative. And 63, we can split up 63 into parts. That is 3 times 3 times 7, because 3 times 3 is 9. 9 times 7 is 63. And 64 can be written as 8 times 8. So we get positive or negative 3 square root of 7 over 8, because for every two numbers multiplied inside the square root, one number will come out. So for these two 3s, 1 3 will come out. For these two 8s, 1 8 will come out. Okay, the question clearly says theta is in quadrant 1. Okay, in the first quadrant, this is first quadrant, second quadrant, third quadrant, and this is fourth quadrant. And we have the concept ASTC. So in the first quadrant, we have the alphabet A. A means all trigonometric ratios are positive in the first quadrant. So since all trigonometric ratios are positive in the first quadrant, so the cosine theta, this ratios are also must be positive. So we can write cosine theta equals to positive 3 square root of 7 over 8. So here we have positive or negative sign. Since theta is in quadrant 1, all trigonometric ratios are positive in quadrant 1. So cosine theta is also positive. So in this positive or negative, we can consider only the positive sign because theta is in first quadrant. So finally, we got the value of cosine theta, that is 3 times square root of 7 over 8. That we can plug in for cosine theta over here. Okay, now let's continue. So 2 times the value of sine theta is just 1 over 8. And cosine theta, we just got the value, that is 3 times square root of 7 over 8. So 2 goes into 2, 1 times 2 goes into 8, 4 times. So when I multiply the numerators, 1 times 1 times 1 times 3 square root of 7, I'm getting 3 square root of 7. 4 times 8 is 32. So I got the value of sine 2 theta, that is 3 square root of 7 over 32.